going to look at the difference. Okay, so solve means you're going to end up with a variable equals a number. Okay, simplify is just combine everything until you can't combine anymore. Okay, and now we've got this thing where I'm going to be talking about equivalent expressions or equations. Okay, and what that is I'm going to end up with an expression equals another expression. Okay, and an expression is made up of variables and numbers. So basically, it's like part of an equation. The expression is made up of variables and or numbers, like a combination of both, and they're separated with pluses or minuses. Okay. Now, when we're simplifying an expression, to be completely simplified, you have no parentheses. Okay. No exponents on numbers. Okay, you can have an exponent on a variable, but you don't have exponents on a number. So if there was like a 3 squared in there, you would actually do 3 squared and make it 9. No parentheses, no exponents on numbers, and all like terms are collected. And all square roots are simplified. So if I had like the square root of 25, I wouldn't leave square root of 25 in there, I would write 5. For this assignment, you're going to be asked to write, what is it, equivalent expressions? Oh, wrong thing. Equivalent equations. So write equivalent . Okay, so I'm going to do number 1. No, I'm not going to do number 1. Number 1's boring. I'm going to do number 3. So we have 3 halves of 6x plus 12 is equal to 14 times 2/7 x. Okay, now the first thing I want you to do, we're not solving, okay? We are not solving. It doesn't say to solve. It says write equivalent equations. So what we're going to do is we're going to pretend this equal sign is a wall that does not cross. Okay, so just you can draw a line down or whatever. Okay, so first thing is we don't cross equal sign. And then what we want to do is we're going to simplify each side. And we're going to do that separately. So we're going to work on one side and then we're going to work on the other side. Okay. So I've got 3 halves times 6x plus 12. When I have a fraction like this, the numerator is multiplication and the denominator is division. So I'm going to look at the 6 and the 12, and do they divide by 2? I'm looking at the 6 and the 12 and seeing if they divide by this denominator. They both do, right? 6 and 12 both divide by 2? Yeah. So I'm going to take this 2, and 2 goes into 6 3 times, and 2 goes into 12 6 times. If they divide evenly, yes. Yeah. And if they don't divide evenly, so here, if I'm doing like this, 2 goes into 6 3 times, and then I do 3 times 3, and that gives me 9x. But if it were something like 3 halves of 5x, 2 doesn't go into 5, right? So if it doesn't divide evenly, I just do the multiplication, and 3 times 5 is 15, and that 2 just stays. So if it divides evenly, we divide. If it doesn't divide evenly, we don't divide, we just carry it over. Okay, so here we divided, and here we just carried.
So like say for number 3, if 2 wasn't...
Yeah, if this was like a 5 here, or if this was like a 5 here, but this was a 12, I could divide the 2 into the 12, but I couldn't divide it into this 5, and so it would look like that on the first half. Does that make sense? Okay, but since it did divide, we'll go ahead and divide it. And then I multiply. 3 times 3 is 9. I have to keep the x. The x didn't go anywhere. It's just hanging out. And then 3, so I do 3 times 3 and 3 times 6. I can't do anything else with the 9x and the 18, so I'm done with this side. So now I'm going to go over to this side. And here I'm multiplying a whole number times a fraction, which is the same thing as multiplying the fraction times the whole number. It's just they're turned around. So I'm going to look at this 7 and ask myself, does 7 go into 14? Yeah, it'll go 2 times. So 7 goes into 14 twice, so I divide it here. And then here I'm going to multiply, and I get 2 times 2, and that's 4x. And now that I've got 4x, I can't do anything else with 4x. So I put the equal sign there, and I'm done. And again, the reason we're doing this is just so you get used to simplifying each side before you try to cross that equal sign. That's just a better practice, so mistakes aren't made. If it wasn't 2/7, let's say it was 2/5. Okay, so if it was 14 times 2/5 x, 5 doesn't go into 14. So I'm going to just do 14 times 2, which is 28, and keep that 5. Okay, so if the denominator doesn't divide, it just hangs out. If it divides, you divide it. If it doesn't divide, you just leave it, and you multiply the numerator times the whole number. Do you guys remember how to multiply a fraction times a fraction? Does anybody need me to go over that? Yeah, you just multiply across. The numerators multiply and the denominators multiply. And then you reduce, or you can reduce first and then multiply. Anybody want me to go over that difference? Yeah, okay. If you have two fractions like, oops, equals, not equals, times 4/9. Okay, I can multiply straight across, and I get 8/45, and this won't reduce because the only things that go into 45 are 9 and 5 and 3. And the only thing that goes into 8 is 2 and 4. So nothing matches, so we're done. Okay, now if I have something like this, so let's say I had 2/5 times, not 10, I don't use 10, 15/18. No, not 18 because that reduces. Hold on. 22. Okay. There are two ways to do this. So I'm going to write it twice. I can go the multiply straight across route, and I'm going to get 30 over 110. But 30 and 110 will both divide by 2. They'll also both divide by 5, or they both divide by 10, however you want to look at it. I'm going to use 10 because that's the easiest. So I'm going to divide the top and the bottom by 10. Not 0. You can't divide by 0. And I get 3 over 11. So if you multiply straight across, you have to see if you can reduce. Or if you want, you can, so this is multiply, then reduce. Or you can reduce and then multiply. Okay, and by doing that, you're going to cross cancel. Okay, I'm going to look at 2 and 22. Like they're across from each other, like in an X. 2 and 22 both divide by 2. So I'm going to divide each of these by 2, and I'm going to get 11 and 1. Okay, so I divided by 2. And then 5 and 15, those both divide by 5. So I'm going to get 1 and 3. And then when I multiply, I have 1 times 3, which is 3, and 1 times 11, which is 11. Same answer, different order. I don't care which one you use. Pick the one you like better. The only thing you can't do is you can't say 2/5 times 15 22nds equals 30 110ths and leave it. No. You have to reduce it. Okay? Okay, we're not going to cross the equal sign. We're just going to work this side, and we're going to work this side. Okay?
So, when it's not like that, you want us to simplify it?
Yeah. So I'm going to do, I have 3/4 times 8x minus 12y plus 20. So I'm going to look at this. 4 goes into 8, 4 goes into 12, and 4 goes into 20. So that works out nicely. So I'm going to divide. 4 goes into 8 2 times, into 12 3 times, and into 20 5 times. Okay. And then I'm just going to write this like this because then, oops, maybe it'll make it clearer looking. You don't have to write this step if you don't want to. But then I'm going to multiply all of these by 3. So I'm going to get 6x minus 9y plus 15. Okay. And now I have an x, a y, and a number. So nothing will combine, so I'm done. So I'm done with this side, so now I'm going to come over and look at this side. And I see that 2 does not go into 5 and 6 does not go into 5. Okay, so I'm not going to be able to reduce those. So all I'm going to do is I'm going to multiply 5 times 3 and times 5. And so I'm going to get 15 over 2x and 25 over 6. And that's because I changed this to a 5 instead of leaving it the 6 that was on there. I can't do anything else with these. And they're not lined up, so when they don't line up nicely, I like to rewrite them so that they line up all pretty. And we're done. Okay. If there were like terms on either side, you collect them before you're done. Now, if you look at the top of this worksheet, it actually says solve. Okay. So what we're going to do is the first thing we need to do is simplify each side. Okay. You know, as we were doing in the equivalent equations, except we're not going to stop. We're just going to keep going after that point. So usually we're going to distribute first if there's any distribution to be done. Okay, so I'm going to distribute this 3 and this negative 4. Don't forget that that negative has to hang out with the 4, so it stays together. So that's going to give me 3x minus 6, and then negative 4x minus 12 equals 19. Didn't do anything to the 19 because I can't. Nothing's happening over here, right? Okay. Then I'm going to collect like terms on each side. Okay. So 3x and negative 4x are alike, and negative 6 and negative 12 are alike. So 3x and negative 4x is negative x, right? Negative 1. And then negative 6 plus negative 12 is negative 18. So far okay on those? Okay, and that still equals 19 because I still can't do anything to the 19 because it's by itself. Okay, now I go on. This side is completely simplified. This side is completely simplified. So I'm going to add or subtract. Okay, I look at what I have. I have negative x minus 18 equals 19. So that helps me to decide, do I add or subtract the number or a variable or whatever. In this case, I'm going to add this number. So I'm going to add 18 to both sides. Negative x equals 37. Right, 7? Yeah, 37. But I don't want to know what negative x equals. I want to know what x equals. So I'm going to change the signs. So x equals negative 37. The reason I picked this one is it's got this little negative hanging out here. We need to distribute that negative in, which just changes the signs. So that negative parentheses 6x minus 12 becomes negative 6x plus 12. And then I'm going to distribute this 3 in. So I get plus 3x minus 30. And I think I mentioned this before, but the largest mistake I ever see is people will multiply the first term but not the second, so don't do that. Multiply both terms. $15 is just by himself, so he stays 15. Negative 6x and 3x go together to give me negative 3x. 12 and negative 30 go together to give me negative 18. And that still equals 15. Okay, I'm going to add 18 to both sides. And I get negative 3x is equal to 33. Divide by negative 3. X is equal to negative 11. If you have variables on both sides, what to do? So the first step is still going to be the same. We're going to distribute if needed. You know, sometimes you don't have to distribute, but if you do need to, you do that first. So 9 times x, 9 times 2, I get 9x plus 18. 2 times x, 2 times 6. So 2x plus 12. 10x and 7, I can't do anything, so that just stays 10x plus 7. Okay, now I'm going to collect my like terms. That's step 2. Okay, and I'm going to do that on each side. I'm not collecting 9 and 10, or 2 and 10, because they're on opposite sides, so I'm only dealing with the one side. So 9x and 2x is 11x. 18 and 12 is 30. Okay. The next thing I want to do is I want to move things. Okay, I'm going to add or subtract to move all my variables to one side and all my numbers to the other. So I'm going to move this 10x over here. So I'm going to subtract 10x from both sides.
What made you move it on that side?
I could have moved the 11 to the other side. Personally, what I do myself is I look at whatever's going to give me a positive variable, but it doesn't really matter. You can move the 11 or you can move the 10. It's just a matter of which side do you want it on, really. I just moved the 10 because that gives me the positive. So what I get is x plus 30 equals 7, because these will cancel. And then I want to get rid of this 30, so I'm going to subtract it from both sides so that the x is by itself. And I get negative 23. Now, once you've made the decision which side you're going to move your variable to, then you have to move the 30 over. Since I moved the x's over here, I have to move the numbers to the other side. So I wouldn't be able to then say subtract 7 from both sides. I mean, I would, but then I'd get x plus 23 equals 0. It's not solved. So then I'd have to end up subtracting the 23. It doesn't make any sense to put that extra step in. And the reason I picked this one is because it doesn't have anything else over here except the x. So I'm going to distribute this 4 and the 5. So 4x minus 12 plus 5x plus 20 is equal to 8x. 4x and 5x are like terms, and that gives me 9x. Negative 12 and 20 are like terms, so that gives me 8 equals 8x. Now in this instance, I don't have a choice of moving x's or numbers. I have to move this x over here with this x because I don't have any numbers over on this side. Do you see that? So I'm going to have to subtract that 9x. If you have both letters and numbers on both sides, you can make whatever choices you want, but if you only have one thing on the other side, you have to move that thing. So 8 equals negative x, and again, I don't want to know what negative x equals, I want to know what positive x equals, so I just change both signs. So x equals negative 8 or negative 8 equals x, it's the same thing. If you don't like to write it backwards, you can write it like that. That's a matter of preference. These two things equal, they're the same statement. This one might look prettier.